go ahead and redo this video all in one shot later on in post so that it's all in one place. So if you aren't able to keep up in class, or your data wasn't ready, or you're like, oh, I had some filtering problems and I couldn't really do anything while you're doing this and follow along, be a little easier to navigate. But I'll record this one also anyway. So last time what we had done is we had taken our data and we had sorted it, right? I first highlighted both columns, then I clicked data and then sort. And I sorted first my X column just from like largest to smallest or smallest to largest, doesn't really matter. And I separated my X's into like 3 different categories. I wanted them to be about the same amount of things in them. After I did that for X's, I did the same thing then for Y's, where I've then sorted my Y category same kind of way. And again, I separated them into 3 different categories. And then I filled in my observed counts table. So I took everything that was like yellow and green, I counted those up and typed the number in. And then I did, okay, everything that's yellow and dark blue, I counted those up and put the number in. And then yellow and light blue, counted them up and put the number in.
Can you do that X, Y, again? Mine's not working.
Yeah, I'll take a look at yours here in a minute. Okay. So I did all that and I counted everything up, right? And then I computed my expected counts. So I just used my expected counts formula. So I'm going to use an Excel formula to do this. So in the cell, I typed the equal sign, and then I clicked on row total, and then I did the Shift 8 to make the multiplication star, and did column total, and did the little slashy for division, and then clicked on the overall total, and pressed enter. And I did that for each cell in my expected counts table. So again, for this cell, I typed equals and then clicked on the 17 for the row total, and then did Shift 8 to make a star, and then clicked on the 16 for the column total, and then typed the slash for division, and then clicked on the 50 for the overall total, and then pressed enter. And I did that for each of the 9 spots, and here's my expected counts table. The thing that is a problem for me is, remember the large counts condition for the valid chi-square test requires all the expected counts to be greater than 5. What do you see here? One of them is not greater than 5. So what I'm going to do is I'm going to mess with the boundaries of my data. So if I look at where the 4.8 is, right next to it is 2 5.1s. I don't really think I want to steal anything from either side of it to try to make that bigger, because I suspect if I pull something from the 12 plus and try to bring it over, this expected count will dip under 5. What I'm going to try to do is I'm going to try to pull something from the 71 plus and pull that up. So I'm going to resort my columns here. So I highlight both my X's and Y's. From the data tab, I hit sort. I'm going to sort the heights this time. And what I'd like to do is I'd like to just take one more measurement from the orange or the light orange and move it into the dark orange. And I'm in luck because I have exactly 171. So that'll work perfect for me. So I'm going to go ahead and make that 71 there where's my dark orange? Where are you? There we go. So I'm going to change these boundaries from 71 to 72s. And what that's done is it's moved one of the things from the 72 plus is now only got 5 things in it. And the 67 to 7 or less than 72 now has 6 things in it. And by updating that, because I wrote formulas for my expected counts, notice what happened down here. All these numbers updated automatically when I changed my observed counts, because I wrote it as a formula rather than typing numbers in and then asking it to multiply and add, subtract, divide. Like, it all updated for me, which is super cool. What I'm going to do next is I'm going to do my calculations for my means and my standard deviations and my R and my chi-squared critical value, or my chi-squared calculated value, and my p-value. Everybody's okay? So I'll do the means first. So I'll do the x-mean first. So I'm going to put a label on it, and I'm going to type the equal sign in the cell next to it. And then what I want is I'm going to use a built-in Excel function. So I'm going to start typing the word average. So Excel starts suggesting me built-in formulas. I want the one that says average. And then I'm going to highlight. So I'm going to left click and like drag the entire column here. So that's all of my X data. I'll close the parenthesis and then press enter. And there's my mean. So we'll do the same thing for the Y mean. So equals, and I'll do average. So I just double clicked on the one that I wanted. Left click and drag. So I drag all my Y datas. And then type my parenthesis and enter. So that's pretty easy. So the next thing I want to do is my X standard deviation. So I'll put a label on there and then type in the next cell equals. And I'll start typing standard deviation, and the one I want here is STDEV.P. That's the population standard deviation. So I'll double click on that one and then just highlight my X column. Close my parenthesis and press enter. And then for our Y standard deviation, we'll do the same thing. Everybody okay there? So the next thing I'm going to do is I'm going to calculate my R value. So to do that, I'm going to do it just like we did on the calculator. So I'm going to type in a formula. So I'm going to do equals, and then I'm going to do my first X value minus my X mean. So I'm going to click on the cell where my X mean is at, close my parentheses, divided by the X standard deviation. And what I'm going to do now is I'm going to apply this same formula to every cell in my X column. But to do that, I need to lock the locations for the mean and standard deviation. So to do that, I'm just going to type a $sign in front of the letter and then a $sign in front of the number. That'll lock that cell, so that cell won't change when I drag. I do want the heights to change because I want this then to work for the next 76 and the next 76 and the next 75 and et cetera on. So I press enter there. Then I click on my cell and you see the little green square in the bottom. I'm going to move my cursor over it till it turns in from a white cross to a black cross. Hold down the left mouse button and drag that all the way down. And what I see now is what I'm getting is that same formula is applying recursively, and we're locked in with our X and Y standard deviations. So that's good. That's our first column, just like we do in the calculator. Now I'll do the y's. So I'll do y measurement minus y mean divided by y standard deviation. And again, I'll go back into my formula now and I'll do dollar signs in front of the letters and numbers for the means and standard deviations to lock those. And then drag that formula down so it applies the whole way through. And then the last column when we did this in our calculator was then to take the product of the previous two columns. So there's that. And then just drag it down. And the R is going to be, let's do this first. I guess let's write down our N. I had 50 data points. So R is going to equal 1 over N times the sum of that column. So to do the sum formula, I just typed SUM into Excel, and then the sum built-in formula popped up. Drag that whole column. So there's my R value. So far, so good. Okay. So next thing I'm going to type in is my chi-squared calculated. So to get that, that is my observed, the formula is my observed count minus expected count squared divided by expected. And I have to do that for each entry in my table. So I'm going to have to type that a bunch of times. So again, observed minus expected squared divided by expected. And just keep adding these bad mama jammas up. Okay, so that's all of them. Press enter. There's my chi-squared calculated value. To then get the p-value for this, I'm going to type in a label. I'm going to do equals. And then what I want is chi-squared dot dist dot rt. And my entry in that should be my chi-squared calculated value, comma, the degrees of freedom for this problem. So that is 4. Remember, the formula for degree of freedom is number of rows minus 1 times number of columns minus 1. So 3 minus 1 times 3 minus 1 is 4. So there's my p-value. So far, so good. I'm now going to make my scatter plot. So to do that, I'm just going to highlight. Actually, I'm going to take the labels with them too. So I'm going to highlight my X and Y's. This time I'm going to go to Insert. And then I'm going to pick the other charts. And this is the kind of scatter that I want, is that first option. So I'm going to change my title. So mine is like height versus shoe size. So X versus Y. So I'm going to have a reflective title. If I click on this, the chart, and then I click on the plus, I want to add some axis titles. So I want to be able to label that. And I'm going to ask it to give me the trend line in there. So I'm going to add those options. So now I'm just going to double click in here and change my label to be reflective of what the data is. So I have shoe size and height in inches. The thing I don't like is the automatic formatting they gave me for these. So what I'm going to do is I'm going to click on the axis here, and I want, nope, that, where did that go? There we go. I want the bars. So I want to change the minimum here from 0 to maybe like 60. So I'll do that. That's much better looking, right? And I might do the same thing here with the Y's. I might change that minimum from 0 to say like 6. Do that. That's a pretty good looking chart now. The one thing I would add to that is if I double click on, or I right click on the trend line and hit edit or format trend line, I can get the equation to display on the chart for me. Everybody's okay there? So we'll compute that by hand here in a minute using our calculations we've just done, but that's that. The other thing though that's useful to do, if you look at the IA, what I'm asking you to do, if you look at building a different type of regression equation, if you find some other better fitting regression equation, you can earn extra credit for considering those situations. To do that on Excel, all you really need to do is like say, okay, what if this is exponential? Look at the equation already changed for you. And if I want to compare, I want to just add that R squared value to my chart. So I click that option. So the bigger, or that R squared value closer to 1 indicates a better fit. So like you can compare these then and just kind of click through and see if any of these give you a better fit than what you had with the linear. Or even if you want to just list them all, like it's pretty easy to just, you know, copy it, change it, you know, copy it and drop it in, change it, copy it, drop it into your paper, whatever, and change it. But that's that. Does that feel okay? For your linear regression, to calculate your A and your B, so the formula for A is your R value times your Y standard deviation divided by your X standard deviation. Notice that matches exactly what I have up there, or at least rounded to 4 decimal places. And then my B calculation is the Y mean minus your A answer times the X mean, I think. Yep. And that's, again, notice I'm getting the exact same answers up there. So your next piece of turn-in for your IA is going to be simply emailing me your Excel sheet. So I should see all the calculations we've done in class in your Excel sheet. It doesn't need to be formatted beautifully. You don't have to do anything fancy. It just needs to be labeled. The numbers need to be there. They need to be done using Excel formulas. So if I click in the cell, I can simply see that you have the right answer. If I look in this cell for X mean and it doesn't have an Excel formula, if it just has the number written there, I'm marking down for that, okay? simply because I don't want to have to check everybody's numbers individually. If it's done through Excel, I can just look at the formula, and if the numbers if the numbers are the numbers, it did it. I'm confident that it did it correctly. I want to just look at your formulas and not have to redo the calculation myself. So that due date on that's going to be Tuesday, so that'll be the next class. If you haven't finished that yet, which I don't know why you would have, because we just did it together and I buzzed through it kind of quickly, that's the next turn in, but I need that Tuesday so I have a chance to look at it and give you feedback before we leave for break, because the Monday we get back from break, IA is due. Do that Monday.
The rest of the IA is you putting it into
So the IA is the paper.
the rest of it.
Writing the rest of the, it's writing the paper, yes. So you've written an introduction, it's probably pretty decent by now, might need still a little bit of minor revision, but that's probably okay. We've started the mathematical processes section, where we're typing in formulas. We can do a little bit more there on Monday after the 8-3 lesson. But that's gonna be coming down the pike. You're free to start that now, right? You don't need your results to write your data collection section. You don't need your results to write the mathematical processes section, right? You don't need your calculations to start doing that. Just like start writing those things out so you don't run out of time. This is like we've done a lot of the hard parts in class, but it's still going to take some time. I would estimate like an hour per section of your paper in terms of writing and proofreading and making sure it sounds decent enough. So between introduction, data collection, process or mathematical processes, results, and conclusion, it's probably 5 hours of writing. Don't wait till last. Well, that's assuming you know what to say too, right? Like, don't wait till last minute. Start in on stuff now.